So in this video, we're going to talk about linear programming. What is linear programming? Why is it important? And how is it similar to setting a goal? Okay, so let's try to analyze this problem, a linear programming problem. So here is the scenario. You are the head manager of the city's Department of Public Works. Your department is making final inspections of two types of commercial buildings to assess building safety. The first type of building is a marketplace and the second is the gas station. Final inspections involve the work of three separate inspectors. First is a plumbing inspector, second is an electrical inspector, and third is a HVAC inspector. So the plumbing inspector requires 4 hours to inspect a marketplace and 2 hours to inspect a gas station. The electrical inspector requires 3 hours to inspect a marketplace and 3 hours to inspect a gas station. The HVAC inspector requires 6 hours to inspect a marketplace and 2 hours to inspect a gas station. Considering the time required for other duties, the plumbing inspector only has 32 hours a week available for inspections. The electrical inspector has 36 hours available, and the HVAC inspector has 40 hours available. So you want to inspect as many commercial buildings as possible in each week. So set up this problem as a linear programming problem. So here are the things that we want to find. So first is A, define the division variables. B, define the objective function. And C, write out the constraints. Lastly, we will graph this function and we will find what are the values that we want to get. Again, maximize the objective function. So with that, let's now start with letter A, define the decision variables. So we talked about the buildings which we want to inspect. And our goal is to inspect as many commercial buildings as possible in each week. So every week. And there is a lot of time for that. So say for example, in a week, the plumbing inspector has 32 hours available. So on and so forth. So we can connect the dots here and define the decision variables in this problem. So we can define two variables in this situation. So let's say X represents the number of marketplaces inspected, and let's represent Y as the number of gas stations inspected. So that's for A, define the decision variables. Let's now go on to B, define the objective function. So the objective function is simply something which represents a goal of the linear programming problem. Oftentimes, it can be in the form of like maximize the cost, minimize the cost, maximize the profit, so on and so forth. In this case, our objective function is to inspect as many commercial buildings as possible in a week. So we can define this as, say, C is equal to X plus Y. We can define C, the variable, as the number of inspections held in a week. So what is the maximum number of inspections held in a week? For example, we can say that this could be 7 inspectors per week. So that means these inspectors can inspect these buildings 7 times in a week combined. Or it could be another number, let's say 10 times a week. So those are the values that are possible. And we can determine that objective function by graphing them out. But first, we need to identify the constraints. Constraints which limit how many inspections can be done in the buildings in a week. So what are the constraints? So let's go back at the problem and try to look at it in another way. So we're going to read through this problem again. And we're going to identify which ones are the constraint values. So as stated, here are the 3 constraints. So let's go to the first statement right here. So it says here that a plumbing inspector requires 4 hours to inspect a marketplace, 2 hours to inspect a gas station. If you remember, those are what composes our variables. So we can say that this is just, in mathematical terms, 4x plus 2y. So that is a statement, mathematical statement. So another statement we can make out of this LP problem is 3x plus 3y. And this came from this statement. Another statement we can make is this, 6x plus 2y. Again, it came from this statement. But we need to make an inequality function. So how do we make that? So as you can see here in this sentence, so we can make our inequality function. So we just translate this word 32 hours a week into less than or equal to 32. So we just put all these values. So we get now the constraint function. So we get 4x plus 2y less than equal to 32, 3x plus 3y less than equal to 36, and 6x plus 2y less than equal to 40. So now that we have the functions that we need, we have to plot this in the graphing calculator. So the graphing calculator I'm going to use is Desmos. So that is what we are going to use. Now we're going to plot these functions. We're going to write them out, and we're going to find the points in which these points can intersect. So let's say function 1, we're going to plot them. Function 2, function 3. So as you can see, they're color coded. And then we're going to find the intersection points. So these are the points in which we can determine what could be the possible inspections that could be done in a week. But at this point, I would just like to clarify that we should add further constraints to this LP problem. I want to say that the number of inspections for each type of building should exceed 0 or should be greater than 0. So the reason why I add this constraint is because the intersection might cross 0. So the intersection of the graph will cross 0 since it's a line. So every line crosses the 0. So we have the x-intercept, y-intercept. And the thing is, we can't have any of these values go to 0. And for the sole reason that it's just simply not possible to do that, because we want both types of buildings be inspected, because that is our goal as manager basically. So we can't let, for example, only the marketplace to be inspected, or we can't let the gas station only to be monitored. And you have to remember that the value that we should get for these should be a whole number, so it can't be a decimal place, or else we have to round off to the nearest small number, or to the nearest integer. So we're going to round down. So for example, if we get a value like 1.5, we're going to round down to 1. We're not going to round up to 2, since that would indicate that we still need more to fill that half in, which we don't have, which is a value that we don't have. So instead, we're just going to round down. But we don't want it to happen. What we want to get is a whole number, basically. So those are just key things to remember. So we add additional constraints such as x greater than 0, y greater than 0, because we don't want a value like that. And so here we build is the graph. So as you can see, we have here 3 intersection points. So we have here 0, 20, 4, 8, and 6.6670. As you may have noticed, we can rule out the two intersection we can rule out the two intersection points since they both have a x and y intercept. So cross them out. So the only option we have here is 4, 8. So automatically this is the point which maximizes our objective function c equals x plus y. So what does this mean? So the total number of the inspections we can hold in a week is just 4 plus 8. And if you just do the math, you will probably guess that the answer is 12. So that means that we, the Department of Public Works, can hold 12 inspections per week. And that is how we maximize the objective function, and that is how we solve the linear programming problem.